rotating 90 degrees, 180 degrees, 270 degrees, and congruent triangles. Given the pinwheel figure to the left, there are 4 right triangles. So we have the right angle here, here, and here. And because of that, we know that plus or minus a squared plus or minus b squared is going to equal c squared. Are the 4 triangles congruent? Well, yes, they are. The hypotenuses of the 4 triangles are radii of the circle, and all radii are congruent, so we can label them with our single hash marks. The smallest angles in the 4 triangles are congruent, so this small angle, this small angle, this small angle, and this small angle, they're all congruent, as well as the right angles that were formed. The 4 triangles are congruent by angle, angle, side, triangle congruence. Rotating 90 degrees in the coordinate plane. Let's show an example first. If we're rotating point A 90 degrees counterclockwise about the origin, we're getting A prime. So you can see that we have this 90-degree rotation. We have a right angle right here. And our original point, A, which has coordinates of 3, 4, after the rotation, A prime's coordinates are -4, 3. This point, 3, 4, is an example. Try to rotate another point 90 degrees counterclockwise about the origin to see if you can discover a pattern. So let's try the point 3, 1. If I was to rotate this 90 degrees counterclockwise, so going in this direction, we would end up being at this point right here. Notice you see how we make the 90-degree angle, and the slope of this line from the origin to our new point is 1/3, and the slope of our new point, or the line connecting this new point to the point of rotation, has a slope of -3 over 1. So those slopes are the opposite reciprocals. And then this new point ends up being -1, 3. So we went from 3, 4 to -4, 3. We also went from 3, 1 to -1, 3. Can you figure out the pattern? Take a moment to pause this video and think about it, and when you're done, unpause it. Well, this can be generalized for all points P in the coordinate plane as follows. X, y goes to -y, x. In other words, you switched around your x and y coordinates, and what was originally y is now the opposite, and it's in the x position. So that's how we get that the rotation of 90 degrees counterclockwise about the origin makes x, y become -y, x. What about rotating 180 degrees in the coordinate plane? For example, if we rotate 180 degrees about the origin of A, we get A prime. For A being at the point 3, 4, right here, 3, 4, our A prime after the 180 degree rotation counterclockwise becomes -3, -4. Let's try another point. Let's say we have the point right here, 1, 5. If we take 1, 5 and we draw our line to the origin, our point of rotation, and then continue it because 180 degrees makes a straight line, we will end up at this point right here, which is -1, -5. Do you see a pattern between going from the original point, 3, 4, to its corresponding image point, -3, -4? What about 1, 5 to -1, -5? Take a moment to pause this video and think about it to see if you can find the pattern, and when you're done, unpause it. So this can be generalized for all points P in the coordinate plane. A rotation of 180 degrees counterclockwise about the origin makes the xy coordinates become negative x, negative y. In other words, the signs change, but the x and y coordinates stay in the same position. How about rotating 270 degrees in the coordinate plane? So if we have a rotation of 270 degrees about the origin of point A, we end up going, again, counterclockwise. 270 degrees will bring us right here to A prime. The coordinates of point A are 3, 4. And after this 270 degree rotation about the origin, point A prime becomes 4, negative 3. Let's try another point. Let's use this point right here. This is 5, 1. If we use the origin as our point of rotation and we go 270 degrees, that's going to be right about here. Notice that the two lines that were drawn form a right angle, and lines that are perpendicular have opposite reciprocal slopes. So the slope of this line connecting the origin and our original point has a slope of 1/5, and the slope of our 270 degree counterclockwise rotation has an opposite reciprocal slope of -5/1. So that's how we know that we have perpendicular lines here, and we can use that same counting strategy to get from the original point to the new point. So this new point, I'll call the first one B. So this one will be B prime. Its coordinates are 1, -5. So we went from 3, 4 to 4, -3, and we went from 5, 1 to 1, -5. Take a moment to pause this video and think about the pattern, and when you're done and are ready for the answer, unpause it. So the pattern for 90 degree rotations clockwise or a 270 degree rotation counterclockwise about the origin is that x, y maps to y, -x. Notice that the coordinates switched places, and what used to be x became -x in the y coordinate position. Next, let's discuss rotating -θ degrees in the coordinate plane. Here's an example. If we're rotating -270 degrees about the origin to get from A to A prime, the mapping will be as follows. We're starting at point A, which has the coordinates of 3, 4, and we're rotating it -270 degrees. This negative sign at the front tells us that we are going clockwise instead of counterclockwise. And after the rotation, 270 degrees clockwise, we will be at this point A prime, which is -4, 3. As you may have noticed, this corresponds to a rotation of 90 degrees about the origin, meaning 90 degrees counterclockwise. If I go this way 90 degrees, I'm also going to get from A to A prime. So therefore, a rotation of -270 degrees about the origin, meaning -270 degrees clockwise about the origin of A, is equal to a rotation of 90 degrees about the origin of A. In other words, it's 90 degrees counterclockwise about the origin of A. And for our point A being 3, 4, we can see that this leads to -4, 3. This can be generalized for all points in the coordinate plane. A rotation of -270 degrees about the origin of xy will yield -yx, because the rotation of 90 degrees about the origin of xy also yielded -yx. Similarly, you could also show that a rotation of -90 degrees about the origin of xy will yield y negative x, and this was equal to our rotation of 270 degrees about the origin of xy, and that yielded y negative x also. We discovered that on a previous slide.